Okay, this video is about how to write dissociation equations. Okay, so the first thing is what you want to do is write the formula or look up the formula if you don't know it, something like that anyway. So here we go. So lithium hydroxide is Li and it's +1. If you remember, hydroxide is OH and it's -1, so the formula is just LiOH. So let's pretend that we have a solid lithium hydroxide, and when you put it in water, water is going to separate it into its ions. So it's an ionic compound. Okay, so that's like an important step in writing these things is first determine if it's an ionic compound or if it's covalently bonded and is a molecular compound. But lithium hydroxide is a ionic compound, so it's going to break into ions. So it's going to be lithium +1 AQ plus hydroxide -1 AQ. Now, what's important here is we want to put the charges up here and we want to write the AQs over here. Now, you should also balance the equation: 1 lithium, 1 lithium, 1 hydroxide, 1 hydroxide. All right? The next one, ammonium sulfate. So we write the formula for it. So ammonium is a positive ion, +1. I'm going to put it in parentheses because sulfate is a negative ion and it happens to be -2. Now, if the charges aren't the same, remember you crisscross them, and so we get NH42SO4. Now, let's just pretend that that's a solid. This is an ionic compound, and so ionic compounds are going to break into the ions that make it up. So it's going to break into the ammonium ion, NH4+1 AQ, once you put it in water, and the sulfate ion, SO4 -2 AQ. Now you balance it and you say, well, I have 2 ammoniums here, so I'm going to need 2 there. Okay, it's important to balance these equations. That's one of the things that you have to be able to do. All right, sucrose is table sugar, so let's see, so it's C12H22O11. Now, let's say we have some solid table sugar. And if you look at this, it starts with a non-metal, and so this is a molecular compound. It's not made up of ions. So when you put it in water, all right, what's going to happen is this solid sugar is just going to be break into the molecules that make up sugar, which is still C12H22O11. And then you just change it to AQ. Now, note, molecular compounds don't break into ions. Ionic compounds break into ions. This is a really important point for the electrolyte lab. Things that break into ions tend to be strong electrolytes. All right, so like these two would be strong electrolytes if we tested them. All right, whereas sucrose would be a very weak electrolyte or a non-electrolyte. We'll just call it a weak electrolyte. Okay, there's no really charged particles, so weak electrolyte or non-electrolyte. All right. So anyway, that's what you would see with the molecular compounds. They don't break into ions. So when you write the dissociation equation, you don't break molecular compounds into ions. Okay, acids are a little bit different. So sulfuric acid is H2SO4. Now acids, we'll just start with like a strong acid or whatever. So basically, what an acid will do when you put it, dilute it or put it into water, it's going to break apart into a hydrogen ion because that's what makes an acid an acid. So it's H +1 AQ plus whatever's left over. If you take one hydrogen away, you get HSO4, and that happens to be -1. All right. Now, sulfuric acid is a strong acid, and strong acids make strong electrolytes. Weak acids make weak electrolytes. That's not that big a deal for the course chemistry to know. If you take advanced chemistry, you need to know it, but not in this course. All right. So acids, you just take one hydrogen off at a time. Okay, let's do this one. HNO3. You can recognize that this is an acid because it starts with an H. So if we had nitric acid, and let's say it's like a strong acid already in the bottle, and then you put it in water, all right, it's going to break into hydrogen ions, AQ, plus nitrate ions, -1, AQ. And notice since it breaks into ions, it would end up being a strong electrolyte. Okay, C6H12O6. Okay, that's glucose. All right, so if you take glucose and it's a solid, if you put it in water, it will dissolve, but it's a molecular compound. And so all it's going to do is break into individual molecules of glucose surrounded by water. And so it doesn't break into ions, so it's going to be a non-electrolyte or a very, very weak electrolyte. All right. Iron 3 hydroxide. Okay, so step 1, write the formula. Iron is +3 because it's Roman numeral 3. Hydroxide is -1. So we do the crisscross because the charges don't match. And let's pretend we start off with a solid of that. Now, it's an ionic compound, so when you put it in water, as long as it dissolves, it's going to break into ions, Fe +3 AQ, plus hydroxide ions, AQ. Now, before you're done, you got to balance the equation. 3 hydroxide, so I'm going to put a 3 right there. Now, this one, ionic compounds that dissolve, okay, if you can get this one to dissolve, it would be a strong electrolyte because it produces ions in solution, and ions are going to conduct the electrical current. So, a quick review here. Molecular compounds do not dissociate. All right, and because they don't dissociate, they're either non-electrolytes or you would see if you were testing them maybe a very, very weak electrolyte. But ionic compounds, they do dissociate when they dissolve, and they're strong electrolytes. Acids can also be strong electrolytes, and some acids are weak electrolytes, but acids do dissociate into hydrogen ions and whatever is left over. All right? Make sure you balance the equations, your dissociation equations, when you're finished with them, and have the correct charges on everything. Okay, that's it.